and a keen eye for the way things work. A tenacious vision to go beyond the next step. Join us for a glimpse into the revolutionary world of Burt Rutan on this edition of Sport Aviation. Welcome to Sport Aviation, EAA's video magazine. For years, Burt Rutan has been showing up at Oshkosh with surprising machines that fly. His first home built was the 3VID-Q, which is a stall-proof delta wing with a canard designed for safe, low, and slow maneuverability. It will give you a taste of what it is like to be behind the stick of a fighter plane.
The basic reason for my using the canard there had nothing to do with performance. It had something to do with an element I was trying to design into the airplane, which was called natural stall limiting. And what that means is that naturally the airplane, when it gets to a certain angle of attack, the canard stalls first or loses its lift first, and the airplane will limit itself at that angle of attack. I don't mean stall and drop, because the wing is supporting almost all the airplane's weight, or most of the airplane's weight. So I was able to find in my model test and wind tunnel test that I could develop an airplane that at forward CG and at aft CG would fly up to a given angle of attack and stop there and not be forced above that angle of attack, and still have lateral directional flying qualities that were satisfactory. So that led me in the 3VID-Q to go out and, in a research way, look at natural stall limiting with the canard configuration. So the main reason that I got into using canards was for flying qualities, a safety issue, natural stall limiting. From there, I went to a higher performance airplane, very easy, which had high aspect ratio wings, and I was able to also have natural stall limiting.
The next breakthrough in the Rutan Air Factory revolution was the introduction of an all-glass airplane. This step led to a whole parade of composite airplanes that have changed our world for good. Airplanes with names as unique as their configurations. The Very Easy, the Single-Place Quickie, and the Four-Place Defiant come to mind.
I got into composites in a quite different way than you would guess. I didn't get into composites for the intent of developing a satisfactory structure for aircraft production. That was not my intent at all. When I built the Very Easy, I built it with a moldless foam and glass method because I had stumbled onto this inside-out fabrication method, which has become known as the moldless composite structural technique, that allowed me to build an airplane without making tooling. So what it did, composites for me was nothing but a shortcut in those days. I'm talking 1974 now. I was able to take a shortcut, build an airplane that was foam and fiberglass very quickly, without having to build tooling. I didn't look at it at that time as being a possible candidate for a home build. I wasn't sure whether a home builder could build a composite structure. Normally it's built in a factory with all kinds of quality control and all kinds of inspection machines and all kinds of procedures to assure quality. And whereas a home builder building out of aluminum, he buys the materials that's already gone through quality control. So it didn't seem, at least at first, that it would be successful to have home builders building the material and then building the airplane. However, I was very surprised when I built the Very Easy. Not only did it build much quicker than I thought it would, but and pace the structure. There was only so many layups, thus only so many work sessions. I found I had an airplane flying in 3.5 months, which was a dramatic difference from the very Vigan. But I also found out something else that was the most important element that led me into the home building with it. And that is, I found that it was relatively immune to imperfect workmanship. Unlike welding, where if you have a bad weld, you could get a crack and the part would break in half. Or like aluminum, where if you bend it too sharply, a crack could happen and go completely across the spar or the rib and fail that way. But I found that even imperfect workmanship would be durable and would have probably a better structural history than a metal airplane or wood airplane. So that discovery, as it were, is what kind of started what has been called the moldless composite revolution, you know, and Jack Cox has referred to it that way, I think mainly because there's so many long easies and very easies and these types at Oshkosh. And subsequent to it, there were a lot of airplanes built using moldless methods.
The next revolution came in the form of the long easy, right after the break. The Long Easy was designed to allow home builders to use a larger engine in their project. Burt was worried that modifications would be made to the Very Easy and would compromise the weight and balance of that configuration. The answer was the Long Easy. Other benefits of the new design were longer range and slower landing speeds, along with better visibility. The Long Easy was an instant success. In 1979, sales of plans were given a boost when Burt's brother Dick broke a closed course distance record by flying the Long Easy for 33 hours and 33 minutes over a course that was 4,800 miles long. This flight convinced home builders that the Long Easy was an ideal cross-country machine. It wasn't long before these strange-looking aircraft were popping up everywhere, especially at Oshkosh. Not all of the Rutan Air Factory designs Burt has teased us with have been accepted by the marketplace. One of these was a wonderful machine designed with the bush pilot in mind. The Grizzly is a short takeoff and landing, capable four-seater with optional amphibious floats. This prolific introduction of one design after another on a shoestring budget is a direct result of the energy emanating from the Mojave. What makes a man like Burt Rutan tick? What is it about him that drives him to create the wonderful things he does? Recently, we met with Burt and asked him what was needed to encourage young people to take an interest in science, math, and technology. Take a listen to some of his core beliefs, and you'll see what motivates him.
The way to get people to think outside the box, the way to get them to be attracted to try new things, is competition. Clearly. These things, for example, that some of the college students do by flying a model airplane that'll lift more weight and reach a goal, it makes them think outside the box because they know if they build something that the other guy's got, they can only do as good as him. Make them want to beat the other guy, and then they have to try other things in order to do it. They know they have to be out of the box. Once you put that up as a challenge, as a goal, something to reach out for, then you don't have to teach them to be outside the box. They'll do it on their own. Creativity, innovation, breakthrough, progress, science milestones happen out of catastrophe, chaos, and failure. And they happen out of spurts. So this issue of coddling students and saying that, oh, let's have a perfect world with no strife, and that'll be a nice environment for us to build and improve our way of life, that doesn't work. In fact, if you do that, we will lapse into mediocrity and boredom and will freeze to death. You've got to have an outside threat. You've got to have something that fires you up to win, that may fire you up to survive. So the very fact that we're way behind in science, mathematics in the schools, probably the best thing we can do is make it real apparent that we're going to lose and we may even die because of it. When the chips are down, when you're scared, when you think you're going to lose, is what then breaks out people's creativity, i.e. it brings out people's courage. We had to invent a hell of a lot of things to go to the moon that we didn't know. Navigation on those levels, propulsion, we had to make computers where we had almost nothing. We had to invent and mature many new technologies, okay? And we did that because we were scared, not because we were comfortable.
Secret projects have long lived in the Mojave, but this one got the world's attention.
Today in schools across America,
Back pain got you bent over? Do painful head...
The original design for the Voyager was sketched on a napkin in a restaurant in Mojave. Dick Rutan and Gina Yeager were tossing around ideas for a new business venture. Burt suggested that they should do an around-the-world flight, an idea which had been the subject of earlier discussions. No one had ever flown non-stop, unrefueled around the world, although several projects were on the drawing board. Burt would design the Voyager, and Dick and Gina would build and fly it. Part of the mystique of Burt Rutan is his fascination with projects that are revolutionary in nature. The problem of designing a vehicle that could accomplish this challenge was right up his alley.
The Voyager configuration really had to look like this, from my perspective. A conventional airplane didn't seem to be possible structurally to do the job. I wanted originally, my goal was that I had a full 10% range margin against flying around the world non-refueled. And that required quite a bit of excess performance out of the airplane than what would be considered the minimum amount. If I would have taken a conventional airplane with a single engine, let's say, that engine, if it was large enough to take off, it would be running at only 13% power during the last several hundred miles, and gradually reducing power throughout the flight. So the problem is a reciprocating engine is not efficient when it's running at very low power settings. So the reason the Voyager has two engines is not just for safety, it's for having the ability to stage the power. The largest engine is shut off a few days into the flight. The smaller engine is brought up to full power for a day or so and then smoothly retarded. And near the end of the flight, I'm able to run as high as 40% power on the remaining engine. So the airplane had to be two engines. Now, if I would have made a twin boom pusher or something, the airplane would be very weak this way because it would be just bending the tail this way. I had to brace this external fuel. Well, first of all, let me explain that the airplane had to have span-loaded fuel. The wings are not anywhere near the volume of fuel that's needed. I need a lot of fuel outside the wings. If I put all the fuel in the fuselage, then the wings would be very weak and bending, so I had to span-load the fuel. You need to keep in mind that this airplane has an aspect ratio of 34. Aspect ratio gives long range. And yet its structural weight is less than 9% of the takeoff weight. That's very difficult to do, and it was considered impossible to do at this high of an aspect ratio. So what my solution was to span load an enormous amount of fuel in these booms. And when you do that, if these booms aren't supported, or if they're only supported by the wing's torsion, they would easily wrench themselves off of there in turbulence and structural dynamics. So I elected to use a very stiff canard. In fact, here's a section of the canard spar. It's very strong, stiff carbon fiber. Very stiff spar up here. so I could brace this wing, or excuse me, brace this boom tank twisting with bending of a wing instead of twisting of a wing. So by bracing that with 2 wings and bending instead of 1 wing and torsion, I was able to achieve a very, very light structural weight. So that configuration essentially fell in place.
5 years later, Voyager flew into the history books.
Welcome home.
The 90s have brought more surprises from the Mojave. We'll take a peek right after this. Welcome back to Sport Aviation. The military didn't buy it, but the crowds at Oshkosh were amazed when Burt showed up with his version of an inexpensive close support fighter. This surprisingly agile jet boasted an asymmetrical design, which allowed placement of the cannon on the right side with the engine slightly to the left in an aft position. This clever configuration prevented smoke from the cannon from choking the air intake that could stop the engine. Sometimes Burt shows up with designs that give us a hint of what's to come.
This is an airplane that I built for myself. I wanted a very fast, very efficient single-engine airplane that I wanted to pressurize, and turbocharged, pressurized, comfortable airplane that's real economic. I wanted something that can go fast while still using the small engines, the 4-cylinder engines, not the big 6-cylinder engines. So I built it in 1987, and I decided subsequent to that not to pressurize the airplane. We've been doing a lot of work on structures and are building a new airplane now with a considerably better structure for pressurization and for manufacturing method. So I'm not planning on pressurizing it now.
Okay, so when will we see this new airplane?
The new one, I should fly it by the end of the year.
Great.
Started on it in March, just doing it part-time, but it's my dream airplane. You know, of course, every new airplane I built for myself is my dream airplane, you know.
Yeah.
His newest dream, for the time being, is the Boomerang.
The reason it's a boomerang is the shape of the wing in the planform. It has a forward-swept wing that's shaped just like a boomerang. What is surprising to people is the airplane's asymmetric when you look at it, but it's more symmetric than a symmetric airplane is when you fly it. The main reason is a twin that looks symmetric has P effect on the propellers. When it slows down, it needs rudder, okay? This one is designed so it doesn't. The P effect makes the airplane symmetric at low speed, and it's asymmetric at high speed where you don't ever notice it. So, hey, I had my trims right on the middle all the way. This airplane flies like a straight airplane.
After the break, we'll take a look at the next step in the Rutan revolution. Welcome back. In 1997, Burt Rutan brought the V-Jet-2, a new business-class airplane, to Oshkosh, fitted with Williams turbofan engines. He expressed his vision, which will change the shape of general aviation for years to come.
The result is that I think this country can get back to building 15 or 20,000 airplanes a year again, like we did in the 70s. This time, they're going to be jet fuel burning airplanes, which is available all around the world, unlike avgas, and there's going to be a lot of export. Back in the 70s, when we built 15 and 17,000 airplanes a year, they were almost all domestic. Now most of them are going to be export. So we're going to help our balance of trade. We're going to create a lot of jobs. We're going to build an industry back up that's been dead. And it's been dead for 2 reasons. One, there hasn't been a good engine. It's been lousy engines for these airplanes. And 2, we're going to revamp the navigational system, communication system, the safety for pilots flying in the clouds. Those 2 things, and we got a whole new industry ahead of us. It uses less fuel, it makes very little noise, and it's what we've been needing for a long time. What's happening here is going to be the biggest change in light airplanes in 50 years. When we move from a tube and fabric airplane with a radial engine
into a Bonanza. This is a bigger step than that, or an equally big step to that.
The most recent innovation from the mind of Burt Rutan is this high-flying research vehicle and delivery system, the Proteus.
You know, we've brought a lot of new airplanes to Oshkosh in the past. This is about I think our 28th new type. And we did something very unusual this year for us. So we've never presented an airplane outside of the U.S. And this year we unveiled the airplane at the Paris Air Show about a month ago. Okay, and so it's here for its first display outside of the Mojave in Oshkosh. We're introducing the airplane to the public and showing what its capabilities are for telecommunications and for atmospheric sensing and reconnaissance and space launch. It launches a rocket at very high altitudes because rockets are more safe to fly outside the atmosphere rather than at ground level. Yes, so this would be our first stage for our spaceship. We're again delighted to have a new airplane here. We hope to have some new airplanes here at Oshkosh next year too. So we'll keep pumping them out and keep bringing them to Oshkosh and keep enjoying the show along with everybody else.
That's all for now. Visit us next time and every time as we take a look at some of the most popular and exciting aircraft designs, visit the world's best aviators, and continue to explore the entire spectrum of recreational aviation. Join us in the left seat for the next edition of EAA's video magazine, Sport Aviation.
Military pilots. Well, they chose black. So all China airline crews are ex-military in China, National China Air Force. The typical Chinese airman crew will graduate from high school, go directly into the military, go through his basic training and so on, and pretty soon he is told, not asked, told which branch he will go into, whether it's bombers, whether reconnaissance, fighters, or what. The captain on this flight had gone through that procedure and he was assigned to bombers. So some 32 years ago now, he went through his basic training. He did his airbags and T-section flights, and he was assigned to bombers. So for some 10 years, he flew bombers up and down the island of Taiwan, all straight along. So for the last 32 years, this captain had never been in an unusual mood. That had a bearing on this subject. Then, About 3 years ago, something else happened of human factors nature, which perhaps bore on this accident. Captain Ho, moving up the social ladder, making more money, and being a rather cultured man himself, decided to move his wife and 3 daughters to Los Angeles so that they could go to their So instead of home being back in Taipei for the last 3 years prior to the accident, home was Los Angeles. That too, I think, had a bearing. We'll see later. 3 days before this happened, the flight logs showed some interesting statements. If you recall the newspaper articles, they said that the number 4 engine quit, and that was the cause, or the newspapers reported this as the cause of the accident. Well, number 4 engine didn't quit entirely. Four days before, on a trip from Taipei to Los Angeles, there's a note in the flight log. Number 4 engine flamed out at 41,000. We descended to 30,000, restarted, and resumed. So on the ground, Los Angeles, they check everything out. They drain the lines, no water, they change the filters. They ground check it, everything runs fine, return to service. The next day, the same airplane flies from Los Angeles to Taipei. Note in the flight log. Number 4 engine flamed out at 45,000 feet. Descended to 28,000 feet, restarted and resumed. Airplane gets on the ground at Taipei. They go through their things, they check a few more things, they replace a few more filters. Airplanes return to service. Now I get to the crew itself. This particular crew had some recent experience which you know. In the previous 10 days, they had spent 5 days on the ground at Jeddah, Saudi Arabia. The time zone there is Greenwich plus 4. It's only a few hours east of Greenwich. They were on the ground 5 days. So this crew had pretty much adjusted to Saudi Arabia time. 5 days. Then they got on a flight to Taipei. The next day, they did a round trip to Tokyo. And the next afternoon, they got on this flight to come to the United States. They departed Taipei at 4 p.m. on the afternoon. And at 8 o'clock the next morning, Pacific time, 8 o'clock, was when the accident occurred. I raised a naive question at the time. I said, what do you suppose the body clock time was on that crew under those circumstances? And nobody could answer. And I don't think there's a soul on the face of this earth that can answer that question. What was their body clock time? After all that mishmash of time zone changes. So that is a big question hanging over this whole investigation. It's an unknown. When the captain of this flight showed up at the airport, the flight engineer came immediately to him and says, look at these log entries. So the captain knew immediately, the flight engineer alerted, this same engine and flamed out on the last 2 trips. So the captain goes over, picks up the phone, and calls maintenance. Hey, what do you tell me about this airplane? And they said, well, we checked this, we checked that, we checked everything that they checked in Los Angeles and what we've done here before, and we cannot find any trouble with that engine. We've ground checked it and it runs beautifully. Well, okay, if you say so. So he signs out the airplane. He took the crew off and he said, gentlemen, here's the order. Here's the chief doing his order. I want everybody on this crew to be watching number 4 engine. I want everybody in the cockpit on takeoff. I want all the brains we can get checking this thing out. Furthermore, on the standard time checks, now they usually will check a certain system every so many minutes during flight. He says, number 4 engine, I want that checked on all of the periodic checks twice as often. If the rule book says you check it every 20 minutes, I want this one checked every 10. So, the captain took all his reasonable measures to protect this engine during that flight. And to say, he said, if there's anything going on, we're going to turn around and come back. Okay, fine. So they took off a little after 4 in the afternoon. Everybody was watching the engine, and it became beautiful. Not a glitch. And here they are doing their periodic time checks on this engine, and all the gauges are working perfectly. And it comes time for some of the guys to change around on their crews. Every so often somebody changes. And there are 5 members to a crew. There's a captain. There are 2 captains, 1 co-pilot, and 3 flight engineers. There's 6 of them. At least there were 6 on this flight, because there were 3 flight engineers, 2 captains, and a co-pilot. And one of the captains and the co-pilot can trade back and forth. So back, anybody been on the 747 cockpit? Captain, co-pilot, jump seat, flight engineer with his rack up here. Another jump seat here, and then back here are the bunks. There's a lower bunk and an upper bunk. And then right here is the doorway going to the spiral stairs down to the lower deck, just outside the cabin door. So they take turns sitting and going to sleep in the bunk. Came time for the switchovers and people are going into the bunks to sleep and so on. The double checking is still going on all this time on number 4 engine. Well, hours and hours and hours go by. Everything's working perfect. And I would guess that after so long time, they say, well, I guess there's nothing wrong with number 4 engine, and things are going along fine. So here we are at 8 o'clock in the morning, going across the Pacific, and things are going lovely. Now here is a historic piece of paper. I found this crumpled up, laying on the floor of the flight deck. This is after the NTSB is all done, and the case is supposed to be closed out. And I took a consultant with me to go study some special stuff, and I had to see this thing, picked it up, looked at it. And this is the captain's announcement about the arrival and the weather at the other end and all that kind of stuff. And that thing has been through 32,000-foot dives. And unprecedented, there's nothing like it in the world. So please let me know about that. And the top part is in Chinese because he makes 2 announcements for the Chinese passengers. And everybody else that can understand it. And on the back are scribbled some of his notes, his subtractions and additions that he gets his numbers and so on. So, he's made his announcement. We're due in Los Angeles in 2 hours, folks. The weather is lovely. Now I have to set the stage. Tell you some of the building that's coming. First of all, they are surfing. Anybody aside from Johnny know what that means or what? Surfing. Yes. No, I had never heard of it either until I was riding up front in the DCA. I should explain, I was Federal Aviation Administration flight center at the time. And as such, I had a cockpit pass, so I could ride up front. So usually when I went any place, I'd ride up front. And I was usually sitting in the jump seat right behind the captain. We were on our way from Hawaii to San Francisco one January, and we were cooking along in a stretch 8. And this old captain with gnarled hands, he had arthritis so bad he couldn't hardly grip the throttles. But anyhow, we were going along, and he turned around and said, "Doc, you notice anything peculiar about what's going on with this airplane?" I said, "No, it feels all right to me." And he said, "Well, you have to watch a little close." I watched, and I still couldn't see him. He says, "Well, we're surfing." And he says, "Watch the Mach meter." So I watched the Mach meter, and it was gradually climbing up to, it went through about 0.84. And he says, and it got up to about 0.86. He says, "See, we're going pretty fast now. We're on the front side of the wave." And sure enough, after a bit, it starts backing off again. Now we're starting to go down into the trough. Now we're down to 0.84. Pretty soon we're down to 0.82. Now we're on the backside. And pretty soon we'll go through the same cycle again. And so I sat there fascinated watching that all happen, and I thought, I wonder if I can feel it. If I close my eyes, see the pants flying out. Can I feel the thing accelerate and decelerate? And I just barely could. If you knew what to look for, you could feel it. Fascinating. And that went on for an hour and a half, just as smooth and pretty as you please, a cycle about every 2 minutes. That was surfing. Well, in the weather book that you studied when you got to be a private pilot, the weather book shows troposphere down here where the weather is, and stratosphere up here, and they got a straight line in between, and it says tropopause. Well, it's not a straight line. There's something going on between these 2 layers of air. And you stop and think that the stratosphere, for the most part, is standing still, relatively still with respect to the Earth. It's rotating with the Earth. But here's the troposphere down here, and in this part of the country, the winds are moving eastward, aren't they? So here's a layer of air moving eastward, and here's a layer of air that's standing still. There's got to be something going on between those 2. And you remember the pictures that the probes sent back from Jupiter and Saturn and so on? And we know for sure there's big bands of gases flowing in opposite directions. And what do you see in between those 2 bands? There's swirls, one right after another. Eddies, all right. In the big scientific terminology, they're called Helmholtz discontinuities. And that's the way gases behave, or fluids behave, when there's 2 layers going in each direction. So, I'm saying that it's not waves like you have on the ocean out here, but there are these swirls every so often. And that's what we were going through. It acted the same way. But they were surfing, because on that thing there, you can see the throttles. All 4 of them cycling back and forth, and back and forth, slowly and gradually. Because the autopilot is set on airspeed holds. This thing had an autopilot, that's what it was set on. Hold the airspeed is what the autopilot is telling the airplane. Well, as soon as they get on the front side of the wave, and the airplane's speeding up, it says pull back on the throttles, and it does. Pulls them all the way back to idle. When it gets slowed down, he said, we need speed, so it pushes them all the way back up to full power. You can see that in the chart. On and on and on. So they were circuit. They had been for quite a while before this happened. Nobody thought anything about it because they see it all the time. But the catch is that on the previous engine failures, it was noted in the flight log, engine flamed out at 450 at idle throttle. Both of those notations are in there as to when it happened. It was an idle throttle setting. And I talked later to the Flying Tiger 747 captain, and he says, I never put the throttles into idle. You do that at about 35,000 and you're almost guaranteed to have a flight on. But, you see, the China Airlines crew was ordered by the Home Office, military orders, you put the autopilot on airspeed hold. So that's what they did. Yes, sir. Put it on. Doesn't matter if the engine goes up, you can back down, start it up again. Put it at altitude, put it back on autopilot, airspeed hold. That's what the book says. So, see how human factors keep creeping into this whole thing? And you'll miss it if you don't look for it. Well, that was my job there to look for it. Well now, here's the airplane going on, and it's cycling. And another important fact to know that this same Flying Tiger captain told me, he says, in my airplane, when an engine goes out, you can't hear anything, you can't feel anything. It's on autopilot, the only thing you can watch and see is the autopilot engine. Well, this number 4 engine didn't go out all of a sudden. It gradually went out. If you know where to look on that thing, you can see it. On one of the cycles, just before it would start going, it came down, came back up just like all the rest of it. But on the next wave, when it came down, it only came back up partway. On the next cycle, it came down and came up a tiny bit, but not very much more. And from the timing on that and the testimony, from hearing what all the crew had to say, we suspect that the flight engineer looked down at the throttle and saw it wasn't moving. George! How you doing, George? So the flight engineer saw the throttle. It was back there, it wasn't moving anymore. So he said, Captain, number 4 engine pointed out. Here it was, all over again. So here it had happened to them. Even though they had been trying to guard against it, here it was. So all of a sudden, here's the captain, the co-pilot, the flight engineer, trying to figure out what's going on. About this time, one of the other crew members stuck his head out of the bunk and saying, well, he didn't get an answer because they were kind of busy on the way. But the reason he had stuck his head out was because as he was laying there, reading his paper, reading whatever he was doing, he says, I heard or I felt something go